Hi, so let's take a look at the problem. It just sent you a problem having to do with robots cars on the Google Classroom. So this is just a follow-up with the solution. So we have two robots can build 10 cars in 30 minutes. Several questions, of course. We can say 5 robots can build how many cars in 60 minutes? That's the question that was posed in the little video. You can add additional questions to look for robots and to look for time. So the unknowns here, these are different questions. So how many robots can build 5 cars in 15 minutes? 6 robots can build 10 cars in how many minutes? Those would be some additional questions. To kind of model the 2 robots can build 10 cars in 30 minutes. 5 robots can build how many cars in 60 minutes? Well, given that we've got this section here, we've got a robot. I'll make sure we've got, we've got our drawing tool. Change my color to a black. So we can see we've got a robot here and a robot here. Based on our given, I have 2 robots. This is 1 car, 2 cars, 3 cars, 4 cars, 5, 6, 7, 8, 9, 10. And all of that can be built in a total of 30 minutes. So this is our 30 minutes. Given that statement, we can go then 1 robot can build 5 cars. I can see that here. 1 robot can build 5 cars still in 30 minutes. The time doesn't get cut in half. That's going to be the misconception kids are going to have. This is why it's called covariation. 2 units are related while the other one is constant. So 1 robot equals 5 cars, 30 minutes. If I double my time, that means 1 robot can do twice as much, 10 cars, in 60 minutes. And I'm using the 60 minutes. I need to change the time because my time over here is in 60 minutes. Many ways to work this out too as well. So I'll take a different approach in a minute. So if this is the case here, I can reason this way. Keeping my 60 minutes, then I have my 1 robot is equal to 10 cars in 60 minutes. Then 2 robots can do 20, 3 robots can do 30, 4 robots can do 40, 5 robots can do 50. So then 5 robots can do 50 cars in 60 minutes. Okay, that's taking time going this way here. So another approach is then 1 robot, we agreed, can do 5 cars in 30 minutes. So I'm going to want to say, well, how many can 5 robots do? I can go this approach. If 1 robot equals 5 cars, and we said this is 30 minutes, then I know times 5 times 5. This is that idea of your proportions if you wanted to continue to go down. So then 5 robots equals 25 cars in 30 minutes. Well, if I double my time, then I know I'm going to have 5 robots can do twice as many, 50 cars, in twice the time, 60 minutes. Okay, so playing with that flexibility, did I kind of do it the same way, didn't I? I sure did. Silly me. Well, not necessarily. I kept the 30 minutes constant. I didn't change the time. I changed the time at the very end when I doubled here. Times 2, 25 times 2, then I doubled over here, times 2. So I doubled my time first on the first time. Over here I didn't double my time until I was finished. So different approaches to working this problem out. Okay, hopefully this little video here could help you out. I like this modeling here and this modeling here of equivalences. This is your ratio. 1 robot equals 5 cars. That's a ratio. So you can either work this out as a ratio too as well, where you have 1 robot over 5 cars equals to, and depending on where I'm wanting to get to, which is going to be in this section here, is 5 robots. So 5 robots equals X number, and here you go, times 5, right, times 5. So then that would be 25 here. Cars. That's kind of working out what we did over here. So hopefully this might help you out. Have a good day. Sorry it took so a while before I got back to you guys, or to you.